Assalamu alaikum. Today, the topic that we are going to address is quadratics, and from quadratics, the point that we are going to stress on is completing the square. First, just let's go through the common expansion, quadratic expansion, when we have two unlike terms, a plus b, and they are being squared. So you can always make two brackets and expand them, and you will end up on this. Similarly, if you have a minus b whole square, you will expand it and you will get. So we can say that once we have these kinds of three terms, we can always put them back in a completed square form. This form is called the completed square form, and this is the expanded form. So the first and foremost idea that we have is, first, let's just search for two things. If we start with x squared plus 8x, now what do we say? This term, x squared, we can consider it as our a square, and the 8x can be considered as the second term, which is the 2ab. Why we are calling it the 2ab term? Because it already has an a, which is practically our x. Okay, so these are the two terms that we have. We are calling one of them a square and the other one is 2ab. Now, in order to complete the square, what do we need? We need a b so that we can add a b square and complete the entire square. If I give you a square and 2ab, you can find your b by simply taking the 2ab term, and if you divide it by 2a, you'll obviously end up getting a b. So this is how we'll try to find our b. Okay. So what is the 2ab term in this particular example? It's 8x. We are not considering the sign at the moment. We divided by 2 is the number and a is technically x. So our b will be 4. Once we get our b, we add the square of b in order to complete the square. And because we're adding something to an expression, so that technically changes the entire expression. In order to balance that out, in order to make sure that we are only changing the form and not the expression itself, we subtract the square of 4 as well. So what do we end up getting? We end up getting a square plus 2ab, and then we get a plus b square. So this portion can be factorized back to a plus b whole square, and then we are left with minus the square of 4 is 16. So this is how we can complete this square. It's the same expression, x squared plus 8x, and this x plus 4 whole square minus 16. It's practically the same expression. But this is the completed square form, and that is the expanded form. Let's go through another example, x squared plus, okay, let's just change the example. What if we have 2x squared plus 10x? Now what do we do with this? First, we need to identify our a square and 2ab. Unless we don't have these two terms, we cannot go on finding b. So we don't have a perfect square here. So what we can do is take 2 common and we are left with x squared plus 5x. Now this portion, this x squared becomes my a square, and this 5x becomes my 2ab. Okay, once I have these two terms, I can find my b by taking 2ab and dividing it by 2. And 2ab is 5x. If I divide it by 2 is a number, a is obviously x. I end up getting 5 upon 2. So 2a square plus 2ab plus b square. And because I'm adding the bracket, I need to make sure I subtract inside the bracket. Okay, so now this portion becomes a perfect square. I'm left with 25 over 4. So 2 multiplies by the perfect square, and it also multiplies by minus 25 over 4. So I end up getting minus 25 over 2. So this is how we can complete the squares. Let's go through a few more examples. Okay, what if I have x squared plus 2x minus 7. Okay. Now what do we do? How do we go about solving this one? How not solving? How do we go about changing the form of this one? So what do we say? I told you that first we need to identify our a square and 2ab. Those are the two terms that we are planning to identify. Okay, we have a perfect square a square. You can simply call my x square my a square, and my 2x becomes my 2ab. And 7 is just a spectator. It's going to stay there. I cannot eliminate it. I cannot remove it. So it's just going to stay there. How will I figure out my b? I'll take the 2ab and I'll divide it by 2a. What will I end up getting? So 2ab, the term 2ab is 2x, and I divided by 2 is the number and a is x. I end up getting b as 1. So x square plus 2x plus the square of 1, subtract the square of 1, and then minus 7. So then this portion becomes, the first three terms end up becoming x plus 1 whole square, and I'm left with minus 1 minus 7, which technically becomes minus 8. So this is how we can complete a square. Sometimes we have this kind of a situation, 3x squared plus 5x minus 2. Let's take minus, for example. 3x squared minus 5x minus 2. Now, this is where students get confused. So, what is our a square? What is our 2ab? First of all, this 3x squared is not a perfect square. So, we cannot consider this entire thing our a squared. We need to take something as common. Now, students often get confused that how can we take 3 common from 5? There is nothing to worry about. When you expand or when you open the brackets, you multiply what is outside to what is inside the bracket. Similarly, when you take common, so you just divide whatever you are taking common by what is inside the bracket. This is what you get. Again, the constant 2 remains a spectator. You're not involving it. Right now, just keep it outside and eventually we'll simplify it with our constant. So this is how we can take common. Now we simply figure out our b. This time I'll try to write it in this way because fractions might confuse you. So what is the 2ab term? It is 5x upon 3. And I need to divide it by 2. And a is practically x. So this will be 5x upon 3. And this can be multiplied by 1 over 2x. And I simplify it, I get 5 upon 6. 3x squared minus 5x upon 3. Now I add the square of b and I subtract the square of b. And then I have minus 2 as my spectator. So now I get a perfect square. Sine of 2ab is always decided by what is between a and b. So we are going to use the sine of 2ab to decide how we put it in the complete square form. A minus b is 5 upon 6. And we are left with 25 over 36 minus 2. So now we open up the brackets, we get x minus 5 over 6 whole square minus 25 over 18 minus 2. If we simplify it, we'll take 18 as the LCM, 36 plus 25, 30, 56, 61. Okay, so this is how we can make complete square forms. This is the one where we consider the entire x square as our a square and then we move on. We don't associate a constant with it. There are other ways of doing it as well. Let's take a few examples when we have perfect squares. For example, if I have 4x squared minus 16x plus 1. Now, in this scenario, I can take this entire 4x square as my a square. And the 16x becomes my 2ab. Remember what we had to do, we had to figure out b, and how are we doing it? We're just taking 2ab and dividing it by 2a. So 2ab is 16x, divided by 2 is just a number, and a is basically 2x. Now, why? Because I'm considering 4x square as my entire a square. I'm considering, I'll just write it over here. If I'm considering 4x square as entire a square, then a will practically be 2x. Okay, so we figure out our b, and what do we end up getting for? So we take 4x squared minus 16x plus 4 squared minus 4 squared plus 1. This portion becomes 2x minus 4 whole square, and I'm left with minus 16 plus 1, which is minus 15. Another such example is 9x squared minus 72x minus 11. Now in this one, 9x squared is my a square, and the 72x is my 2ab. So how do we figure out b? We take the 2ab and we divide it by 2a. 2ab in this one is 72x. We divide it by 2, and a will now be 3x. Why? Because I'm considering the entire 9x square as my a square. So what do I end up getting? 6, 12. Okay, so now 9x squared minus 72x plus the square of 12, subtract the square of 12 minus 11. So the first portion becomes a perfect square, 3x minus 12 whole square minus 144 minus 11 is minus 155. So this is how we can complete different squares. Now we'll go on to the next topic in the next video. Thanks for watching.